Good day, prospective teachers. Welcome to mathgotserved.com. And this clip, we're going to be going over problems 1 to 5 of the Praxis study guide for core mathematics. All right, let's take a look at question number 1. It reads, in the Venn diagram above, so this Venn diagram given here, circle G represents the integers 2 to 10 inclusive, and circle H represents the integers 6 to 12 inclusive. Question: how many integers are represented by the shaded region? Now let's go over a quick vocabulary term that you need to know in order to solve this problem accurately, and that is the word integer. Okay, so what do integers represent? So integers are basically whole numbers, their opposites including 0. Okay, so examples of integers are -3, -2, -1, 0, 1, 2, 3. So if you count all the whole numbers, their opposites including 0, you have the set of integers. Okay. All right, so what we're looking for is basically the cardinality or number of elements of the set that falls in this region right here, the shaded region. The shaded region basically represents the intersection of set G and H. Okay, let's write that down. The shaded region represents the intersection of sets G and H. The notation for the intersection of two sets is given by G intersect H. Alright, so the task is to find the number of elements in this set, or the cardinality of this set right here. Okay? Alright, so let's go ahead and specify exactly what G intersect H means. In the context of this problem, G intersect H represents what? What does it represent? It represents elements in G and H. Okay? So if you have a region that's an intersection of multiple sets, the amount of elements in that intersected region represents the amount of elements that are in all the sets that make up that intersected region. So in this case, we have G and H together make up the intersected region, so the elements in this set will be all the elements that are in G and H together. Okay? Alright, so let's go ahead and determine what this is. So let's do this by first of all listing the elements in the bigger of the two sets. The bigger of the two sets is G. So set G is given by all the integers from 2 to 10 inclusive, so we have to include the endpoints. So we have 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Okay, so that these are the elements in set G. Now let's go ahead and list all the elements in set H. Now when we're listing the elements of set H, we're going to write it in such a way that it's easy to see what the intersection of the two sets is. Okay, so what am I talking about? Well, the elements in set H are the integers from 6 to 12 with the endpoints included. So the integers from 6 to 12, I'm going to align my starting element in such a way that it lines up perfectly with element G. Okay, so I'm going to put a 6 here. 6, 7, 8, 9, 10, 11, 12. Alright, so with this configuration, it's easy to see the elements that are present in both sets. Alright, that represents the intersection. So let's go ahead and identify the intersection. So these elements right here represent the intersection of the two. Intersection basically means that those elements are present in both sets. Okay? Alright, so this set right here represents G intersect H. G intersect H is the set 6, 7, 8, 9, 10. Okay? The problem asks for how many integers are in the shaded region or in the region of intersection. The word for the number of elements in a set is the cardinality, okay? In that, the notation for that is the absolute value. So the cardinality of G intersect H, or the number of elements in G intersect H, is 1, 2, 3, 4, 5. All right, so let's go ahead and write down our final answer. The number of integers um, in the shaded region is what? Is 5. Okay? So the answer to question 1 is option letter D. Alright, let's take a look at question number 2. It reads, in the figure above, C is the center of the circle. Question, which of the following must be true? Okay, so we have statements concerning the lengths of QC and RC, QRRC, and then the perpendicularity of QC and QR and QRRC, and then if triangle QRC is an equilateral triangle. Alright, just a real quick vocabulary concerning what the radius is. The radius of a circle is basically any line segment that starts from the center and ends at a point on the circle. Okay? So if you look at this, you can clearly see that we have two radii here, RC and QC. What is QR? QR is a chord, okay? Any segment that connects 2 points in a circle is a chord. So QR is a chord. We don't know anything about the measurement of QR, okay? So let's leave that out for now. But we know something about QC and RC. So one thing to note about the radii of a circle, as indicated here, is that all the radii, you have infinite number of radii on a circle. The word radii is basically the plural for radius. There is no such thing as radiuses. You could call it radii, okay? So all the radii of a circle are of the same length because you're basically the distance from the center to a point on the circle which is equidistant. That's basically how a circle is formed, okay? So QC, segment QC and RC are both radii, of what? They are both radii of circle C, circle C. Okay? So what does that mean? Well, since all radii have the same length, what does that tell us about segment QC and QR? QC and QR, since they're both radii and all radii have the same length, it follows that they have the same length. Then QC is equal to RC. Okay, so we can just basically state that QC and RC have the same length. So this segment here is congruent to this segment. That is all we know. We know that that is true. Okay? Now, equilateral, we do not know if this is equilateral or not. If this were equilateral, guess what? You will be told that QR is congruent to at least one of these two segments, or if you're told that this angle right here is 60 degrees, then you can show that it's an equilateral triangle. But you cannot make any assumptions. If you want to know what must be true, you have to go with um, what you're given. And the only information we're given here that we know for certainty is that QC and RC are both radii, and since they're both radii of the same circle, they must have the same length. So the answer to question 2 is option letter A. Okay, let's take a look at question 3. It reads, which of the following equations expresses the relationship between x and y in the table above? Alright, so you have five equations of lines given in slope-intercept form, y equals mx plus b. One thing to keep in mind is that if you want to find the y-intercept, all you have to do is set x equal to 0, and that will give you the y-intercept of any function. In the case of a linear function, the b value, when the equation of that line is written in slope-intercept form, represents the y-intercept. Alright, so the formula that's going to guide our problem-solving process is the slope-intercept form of the equation of a line. Alright, slope-intercept form, and that is given by y equals mx plus b. Alright, why are we using this form? Well, if you look at the options we have, that's the one that's more consistent with it. Alright, what do m and b represent? M is your slope, which can be computed using the formula y2 minus y1 divided by x2 minus x1. B, we talked about that earlier, represents the y-intercept. There are different ways you can compute it. One easy way to do that is by evaluating the function at x equals 0, and that gives you the y-intercept. Okay? Now, if you take a look at this table, you will notice that the y-intercept has been conveniently provided for us. This table has given us the output value when x is equal to 0. So this y value right here is your y-intercept. Okay? Alright, so let's write that down. Since 0, 5 is on the line, what does that tell us? It tells us that when you evaluate the function at the input value 0, you're going to get an output of 5. Okay? And that is exactly what the y-intercept is. So your y-intercept b is equal to 5. So we know one component of the equation, which is that b is 5. So if you take a look at the options we have here, we can eliminate distractors. Any equation that does not have a b value of 5 can be eliminated. B has a b value of 6, that's no good. A is good, C is good, D is no good since it has a b value of -1, and E is no good since it has a b value of -5. Okay? Alright, so we've narrowed it down to two options. What will help us find the final answer? It's going to be the slope. Alright? So M is y2 minus y1 divided by x2 minus x1. So we just need any pair of points here. Okay, so if we use the first point using 0, 5 as the first point and 2, 11, we know what we can assign values to x1, x2, y1, y2. This is the first point, so this is going to be my x1, y1, and this is the second point. This is going to be my x2, y2. Okay, now let's figure out the slope. So the slope m is going to be y2, 11, minus y1, 5, divided by x2, which is 2, minus x1, 0. Alright, 11 minus 5 is 6, 2 minus 0 is 2, 6 divided by 2 is 3. Alright, so this basically helps us to see that m is 3. Okay, and the y-intercept b that we determined earlier is 5. So if we put these two pieces of information together in the formula that we wrote earlier, y equals mx plus b, we're going to have the final answer, which is that y equals m, which is 3, x plus b, which is 5. Answer to question number 3 is option letter C. Okay, let's take a look at question 4. It reads, the table above shows the distribution of men, women, boys, and girls in a group of 48 individuals. If one individual is to be randomly selected from the group, what is the probability that the individual selected will be a woman? Alright, let's start off by writing down the formula that's going to guide the problem solving process. So the formula that we're going to be using is for computing the theoretical probability. Okay? And the formula is as follows. The probability that you get an outcome A is equal to the number of desired outcomes A divided by the sample space, or the number of possible outcomes. Okay? So let's write this down in verbal format. So n of A is basically the number of desired, what you want, desired or favorable outcomes, and then that is divided by the total number of outcomes or possible outcomes. Okay, so divided by number of possible outcomes. Alright, so A basically represents the event that the individual selected is a woman. Okay, so that helps us to see that the number of desired outcomes represents the number of women, which is n of A is equal to 18, which is the number of women. And the sample space. And then n of S, the number of the sample space, represents the total number of individuals. Okay, so that's 12 plus 18 plus 10 plus 8, which is equal to 48. Alright, so this is the total number of individuals. Alright, we're ready to compute the probability. So the probability that the individual selected as a woman, P of A, is equal to N of A, number of women, divided by the total number of individuals. Okay, number of women is 18, divided by the total number of individuals, which is 48. The greatest common factor of 18 and 48, let's see, we know 3 goes into both of them. 6 goes also. So let's divide by that. So divide the top and bottom by 6. 6 goes into 18 3 times. 6 goes into 48 8 times. Okay, so we see 6 is the greatest common factor because when we divide by that number, the resulting fraction cannot be simplified any further. So the answer to question number 4 is option letter D. Alright, let's take a look at question number 5. It reads, when 641.29 is divided by 10, which digit of the resulting number is in the tens place? Now, something to recall when dividing numbers by multiples of 10 is that the decimal point moves either to the left or to the right by the number of zeros that that multiple of 10 has. Okay? So when you divide by multiples of 10, you move the decimal point to the left by the number of zeros that that multiple has. and then when you multiply by multiples of 10, you move your decimal points to the right by the number of zeros that that multiple of 10 has. Okay? Now, in this particular case, we are dividing 641.29 by 10. We have only one zero. So remember, when you divide, you're going to be going to the left. And then when you multiply, you're going to be going to the right. Okay? We have only one zero here, so we're going to be going one place to the left. All right? Just because there's one zero. Now, why is that the case? Well, let's take a look at this. We have 641.29 and 10. The decimal point for the 10 is right here. Now, if we move the decimal point of the numerator and the denominator by an equivalent number of places, the resulting quotient remains unchanged. Okay? Now, when you move 10, you move the decimal point one place to the left, and you move the decimal place one place to the left. The numerator and the denominator, you have 64.129 divided by what? Divided by 1. If you divide any number by 1, what do you get? That's the identity on the division, right? So you end up with exactly what you started with, 64.129. Okay, so that's the reasoning why you basically count the number of zeros and move the decimal point by equivalent number of times to get the resulting quotient. All right, so this is the answer. This is an intermediate answer, it's not the final answer. The final answer calls for the place value of the digit in the tens place. Okay, so let's go ahead and review our place values real quick. Let's start from the digit on the right. So after you have the ones place right here. So starting from the ones, if you go to the left, you have the tenth. If you go to the right, you have the tens. So this is tenth, this is hundredth, and this is thousandths. So let's start with 9. 9 is in the thousandths place. You always start naming from the ones place, okay? So thousandths, this is the hundredth. So the 2 is the digit that's in the hundredths place. And then 1, don't get distracted by this, okay? There's only one ones place. All right, this is the tenths place. So this digit right here is in the tenths place. And then we already indicated what this is before. Is basically where you start orienting your names from. This is the ones place. You have exactly only one ones place. To the left of that, you have the tens place. All right. So you see what's happening here. If you go to the left of the ones place, you just have tens, hundreds, and on and on and on. But when you go to the right of the ones place, you have fractional values. That's why you have this THS component added on. All right. This is not a fraction. This is a whole number. Okay. So it's not a fraction. So that's why you just call it tens. And then when you go on, you have tens, hundreds, thousands, and they're whole numbers. But when you go to the right of the ones place, you have fractional. So you have a tenth, 1 over 10, hundredths, 1,000. So let me just show you what I'm talking about. So this one, for example, the tenth is 1 over 10. Hundredths is 1 over 100. Thousandth is 1 over 1,000. That's why you have this TH because they're fractions. All right, so the question says the digit that is in the tens place is what? So the tens place is 6. That's the digit. Answer to question number 5 is option letter D. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial helpful in your preparation for your upcoming Praxis Core Math um, exam, do give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any math concept on the Praxis Core Math exam in general, just place it in the comment section below and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to the remainder of this review series. Do visit our website at mathgotserved.com for access to all the formulas that you need to know to pass this exam and also other great tips, tools, and tutorials to help you to be successful with this test. Thanks again for watching and have a wonderful day. Goodbye.